Okay. Today we are going to talk about introduction to software testing. And this is the main part of this course. It will be the idea of one of the topic that you need to use on your fourth year. If you study the fourth year and you're going to start working on your software engineering project. Normally, the process will contain 4 or 5 main part of document, and which are software requirement spec, software design document, software testing, and unit test. And for summary and testability document, there will be 6 or 7 standard documents that you must produce, and there are 4 main process that you need to show your artifact or your document when you want to present the progress on your software engineering project. And yes, in the project, there will be 2 parts of testing document. It will be test plan and test the code, and we will talk about that later. What is a test plan and what is test the code? I will give you that introduction to that things maybe tomorrow or on Wednesday. Anyway, let's start. When we talk about the software testing, actually, I just expect more students, just like this one. From this example website, is a website that we do something. We have some kind of currency exchange. We have some kind of source from THB, USD, and EUR, which represent Thai baht, US dollar, and Euro currency. So this web will try to compute the input as we want some kind of currency, which is from 30 THB. And if we convert it to US dollar, it will show the result like this. This is a website. This is one piece of example of software. So this is working. It's work. How can we sure that it's working? You may say that visually you can see that this program is working. This web is work. This web page is working. If I try to change something like this and I calculate again, you get a result as an output of US dollar. If I change this to euro and I calculate it, we have some kind of a changing rate between euro and US dollar. The problem you find, did you have any idea how should we test this? Hello, anyone here? Try different min and max value. Okay, this is one thing. What should be the maximum value? Is it work? Still working? If I input, what happened? So change to NaN. If I input something like this, this is maximum. It's still working. So what should be the maximum number? Maybe it depends on data type. It depends on how this back end make a calculation. But how about minimum? What should this be? If I input 0.001, it's still okay. But when it's less than, what happened? It will round up to 0. So there are some little things that we need to be careful when we change from this. Okay, so what I'm doing is that I demonstrate the idea, the basic idea of what should be a software testing. So if the software can run, it doesn't guarantee that it's working as we want. That's why we need to do software testing in our software development project. You see that, okay, there will be some is 0, 0, 0, still 0. Like this, there are some behavior of the software that we expect it should be something, but when we run it, it doesn't happen as we want. As just from your answers, your suggestion, try different minimum and maximum value is okay. And how about anything else? If you recognize that this is comparing to today is $35.89, but here how this one is 30. What does this mean? The software, the calculation part is working, but the scale, the exchange rate is not correct, right? This is the thing that can happen because it's a fact that the exchange rate currency exchange rate change, not just every day, sometimes it's hourly, but and sometimes it's just like daily, hourly, and it's always changed. It's not fixed so for so very long period of time. But this program is working, but it's implement the exchange rate at 30 baht, and it's fixed. Again, does the software work? Can it run? Yes, but is it correct? Is has some part of the code that is correct, is work, but it's not working as it should be, as it should be expected. And that is why before we deliver the software, we need to check, we need to find a way of checking on whether the software is running as we expected or not, whether the software is running as the customer expected or not. Otherwise, you cannot deliver the software, or even you already deliver, you will get rejected, or you do many, the customer will need ask you to revise or check. And this is not a good manner to deliver a bad and unprecise software. It's not good manner, it's not good practice to deliver the software with the error or with the something which is not running as expected. So this but I'm talking about this to show that normally we can create a software which can be run. And sometimes, but the running software sometimes it's not working corresponding to the user requirement. And that's fine. We need to do some kind of software testing. And here, I just from the example of that website, that is important to test. I assume that the answer to this question is yes, it's very important to test the software. And the key idea of software testing, normally on this class, and refer to our curriculum, the software testing will corresponding to the V model. The V model is called, this model is called the V model because the sequence of this is like the character V, right? It's just like some people, or maybe you think about it as a diagram, but okay, we name it as the people name this as a V model. If you have some going down to the bottom and then going up to the top, when we write down the alphabet of character V, it write down like this. Scroll right down until this point and going up. This model will represent the proper idea of generating the test regarding to your software project. And okay, this is a main theoretical thing that you should understand, and you should be able to depicting to remember this idea very well. It's reduced throughout this course. Next, the explanation is the V model, which show the relationship among different artifacts, express how important among them. It's mean that in software project, we have requirement spec, which is you already studied from last semester. You need to requirement analysis, and then you have software design. You already studied software design architecture and also detail design, which is related to the architecture design, and the low-level design, which is related to the software construction. Three of these will give the output artifact or output document as requirement specification, design specification, detailed design specification, and after this thing finish, the next thing that should be done is coding or implementing the software. And after the coding start, we can start the process which corresponding to the detailed design. That kind of process is unit testing. So it's a match up between detailed design and unit testing. And with the system design, we are matched up for this kind of design with integration testing. And for the requirement specification, normally we are going to map this acceptance testing with the requirement specification. This is the model corresponding to, if this is an artifact, the output of each software process, so starting from requirement to design, detailed design, and coding. The theoretical view, theoretical practice is that you need to test at least 3 levels, which is the first level, which is unit testing, the second, integration testing, and the third level, which corresponds to the requirement spec, which is acceptance testing. This is theoretical. This is a theoretical guideline of how you should test your software. So this slide will give you an idea of what is the software testing. Can describe in many aspects. For example, we have software testing is a process of demonstrating that errors are not present. It means that we try to demonstrate every aspect, run every possible way of our software to show that there is no error in our software. What else? Software testing is to show that the program is performed as its intended, functional correctly. Again, it's the same meaning, but slightly different presentation of the common set of the word. The program is performed its intended function correctly. The function is performed correctly according to our program. What else? The software testing is a process of establishing confidence that the program does what it's supposed to do. Yes. And testing is a process of executing a program with the intent of finding error. The errors. Errors, maybe one or many, but normally we find a lot of errors. So I just put S here. The thing is, this is some aspect, some simple explanation of what is the software testing. It's a definition. Or according to the theoretical academic point, software testing must consist of a dynamic verification of the behavior of a program on a finite set of a test case, suitably select from the usually infinite execution domain against the expected behavior. This is a well-preserved, well-explained in the idea, the core idea of software testing. We are going to perform a dynamic verification. Dynamically verifying the set of behavior of the program to check whether the program working as we want or not. Just like the previous example on the website. But the next question is, how long do we need to perform to make sure that there is no error in our program? We don't have an infinite time, and usually the testing process will be just a week or 2 weeks before software is delivered. Just like it's really the last part of the software, the almost last part, except the deploy and maintenance. So in some software project, they didn't test it because they don't have a time, or in some project they have a very limited time. And if you have a very limited time, it means you have to find that you need to be efficiently find the proper test that guarantee the error will not happen. If you test everything and the software is passed the test, you can convince that there will be no error in the software. That is why it said that dynamic verification of the behavior of a program on a finite set of test cases. We can have infinite test case. Can we do that? Sorry. Can we do that? Can we have infinite test case? No. The reason is we cannot test software forever. If the testing process is not finished, how can we deliver the software? So it means that we have a very limited time. So to be effectively test, we need to carefully select how to test the software, because we have actually we need to find a proper finite set of test cases which are suitably select from a usually infinite execution domain against expected behavior. So it's been that can we test this forever? Yes, if you don't want to deliver it, but this is work. Yes. So when should we finish this testing? There's no exact answer, but ideally it's been that when it's working as it's intended to work, it's working corresponding to what? If you don't know the answer, get to the free module. If everything is working, that we perform unit testing is working corresponding to the detailed design. We perform integration testing and it's working corresponding to the system design. We perform acceptance testing and it's working corresponding to the requirement specification. It means that, okay, that should be the proper expected behavior that we can expect. Okay, that is the explanation for this phrase. And this sentence. It's very important idea. The dynamic here is the definition for testing. Testing always execute program input, and we need to provide the dynamic input into the program. In order to make a verification, if we change some things, does the software behave as we expected or not? And the finite here is mean that we have limited resource and schedule, but normally we have unlimited test requirement. And suitably selected here is mean that we provide proper test technique and test cases. And against the expected behavior, expected word here is mean the outcome of behavior, outcome of the behavior, or how the expected behavior is written on requirement specification. So this is some explanation. This is an explanation for what should be consist of for the software testing. It's a dynamic verification process of behavior of the program on a finite set of test case, which is suitably selected from the usually infinite execution domain against the expected behavior. So 4 of these words is the key thing when you try to design the test. Since we have finite resource and schedule, we must select the proper test technique and test case. And we select the proper test technique, test cases, and find out the proper input, which is dynamically cover every expected behavior of the software. This is a theory for testing. What does it look like? We try to find correctness, completeness, security, and quality of the software during the testing. And here is some terminology. Error is mean mistake. People make a mistake while coding. Fault is a result of the error or a defect. We have error and fault is different. Carefully use this word. We have the error. Yes, we have a mistake or bugs. We have a fault as a result of an error, which is we have a defect in our software. Failure occur when fault execute. Incident is when the failure occur. We do tests to find a failure or to demonstrate correct execution. And here you may heard some word that we talk about test case. The test case is identity of the test set. What does it mean? We will talk about this later, but just like how many test cases corresponding to this UIS, how many test cases corresponding to this function or this design. You need to be well defined, and that kind of test case is based on the idea of selected the dynamic coverage of the input. It will be reflected in the test case. And this is some kind of scenario. The program behavior, which one should be the best? Left-hand side or right-hand side? Yes, because we have the expected, we have specification, which is collapse or matching with the observed program. It means that the program working corresponding to the specification or to the expected document, but in the right, in the left, there's nothing match. And this is if you have something like this, it's good, it's not good. And this is a specification and the program. How about test? Yes. If you have from this diagram, if we have bigger value of 1, it means everything is matched, which represent that specification corresponding to the program, and the test can cover the program which is corresponding to specification. But if we have something like what should I do? Oh, so here, if you have something like this, nothing match. This is good. No, there's a big problem in your software project. There's a big problem in your team because we had some people try to develop the program which is not correspond to the specification, and also the test is not matched with the specification, and also it's not matched with the program. This is a big problem if you can realize that your project is something like this. That is not a good software project. It's just a separated part of work and it's not related together. It's not a good software engineering practice. Okay, so that is we try to maximize the value of 1, which is represent the overlap, the collapse, the matching between among requirement specification, the program, and the test. Yes, this idea of the idea of software testing. In some practice, if you have something like this, what does this mean? You have specification which is get along with the test, but the program is not set that the dev team doesn't work corresponding to the requirement spec, and it cannot be tested because if the software is not corresponding to the specification, it's not after if it's implemented. What should we do? Should we do this? Or should we do this? We should change the test corresponding to the program instead and don't care about specification? No, cannot do that. Okay, we must create specification which is corresponding. We need to create a change. The test plan, the test corresponding to the specification, and the program must well behave corresponding to the specification and test. That is the ideal scenario. But to make something like that is the team needs a lot of practice and experience and very good manner and software engineering practice. And there are some kind of wording that you need to be careful. The verification and validation. We verify. Verification we are going to ask question about are we building the product right? We evaluating the work product. Verification, we are going to evaluate the work product, which is the plans, requirement spec, design spec, code, test case. We're going to do this by review or walk to verify or check by the test case. But validation is a process. Process of that we are checking, are we building the right product? And we are going to evaluating the software during or at the end of the development process, which is we are going to evaluating on the real software, or it means that we are doing validation or testing whether it's valid or not corresponding to our requirement. And this is just a level of testing. Requirements is a V model that is already talking about, and level of testing to this three level it should represent correctness, completeness, security, and quality of the software throughout the test. And this is what is this? In this level of testing, we have acceptance test or user requirement specification for user acceptance test. This is an example. We have some kind of. This is an example test document. We have a test case. We have actor, we have precondition, we have basic flow, we have extension, post condition, special requirement, and with this is the name of the test. And description. This is example document. And this is an example for unit test. We are going to test method ABS. And this method has one parameter input and return the double as an output. And this said that this method will return absolute value of a double value. If argument is not negative, the argument will return. But if the argument is negative, the negation of the argument is returned. We have some kind of special case, which is argument is positive 0 or negative 0. The result is positive 0. If an argument is infinite, the result is positively infinite. If the argument is NaN, the result is NaN. In other words, the result is the same as value of expression, something like this. So we have parameter A input, and return the absolute value of the argument. This is an example of unit test. And this is an example of integration test. We find something similar. This is sequence diagram. And integration test will design the integration or method call among the object inside the program, or the method call among the API, or the method call among the component. It should test whether this out of this process, when we put together, is working as we intend or not. This is the idea of integration test. So what should be the objective of testing? So you say, like, to verify different property, whether we have conformance, corrective, or functional. Testing is fun to do some kind of reliability measurement, and we do some auto testing for usability evaluation. And this slide, we will have some kind of guideline. There are many kind of testing in many aspects. For just like for aspect of acceptance test, qualification testing, we have objective for check the software against user requirement. Customer check the requirement, whether it's have met or not. Program hit the target of the market and may or may not involve developer of the system, because when we try to do acceptance test, qualification test, this will be at the user level. Sometimes developer will not get involved. Installation testing, like after software acceptance test, we do some kind of verify for the installation is matching with the environment or not. And with that, if there are some kind of problem, since there are software, the hardware change, yes, we need to do some kind of configuration testing for installation test. And we have alpha beta testing. The alpha tester is for the in-house test. Beta is for external tester to test the software. And user report problem of the product, maybe external or in-house user, and it's uncontrolled. It's often, and this kind of test will not be referred to the test plan. Just like when we have some kind of software or game release beta, some people can download it and play and give some comment. And then this objective of testing, we have conformance functional collective testing to validate the observed behavior of the test software, whether it's conform or it's corresponding to the specification. And then we have some kind of reliability achievement evaluation, just to identify the change to improve the reliability, to check the operational profile, or we try to make some kind of statistical measurement of the software, whether it's reliable or not when it's done on some, just like when you deploy your web application, you need to check whether it's compiled with the web server or not, and you need to do some kind of statistical measurement on how it's behaved and whether its operation. This is something to check. And this is an example of objective of testing. We do performance testing for test performance of the system, check the capacity, response time, file limitation of the system, and how to do some kind of volume testing or load test. Okay, the other thing is space testing. Exercise the maximum of design load and look for incidents that happen when the system is full load. What happened to your system? This is some kind of thing that you need to be tested on your software. And back-to-back testing to validate the function. Single test that's performed onto implemented version of the software product, then compare. So what does it mean? It means that when we have the first version is released, and then we try to release the second version. So we have to perform back-to-back testing whether the new one is working validate. Every function is working as we intend for comparing the old one and the new one. It's a kind of back-to-back testing. And recovery testing is just like aim for simulate disaster situation, just like the power is down or the system is down, how long it should be how long the system need to get back to the operation environment, something like that. And configuration testing, the test program which may serve different user, analyze software under various specified configuration, just like we deliver application to different preset organization, and they serve different type of user. So you need to do some kind of configuration test, whether they can log in, they can access the proper folder, proper page, or proper resource in the software or not. And usability testing, you can test for how easy for end user to learn and use the program, including this kind of usability. We hand on the documentation and check how effective function is spotting the user task and ability to recover from user error. This is some kind of from slide number 21 to 32. It will be guideline objective of testing. And this is a proper, this all of this testing, actually it must be conducted on your software project before you deliver the software, or after you deliver software, and not after or while you deliver software. And okay, and precondition after you deliver software, you may check whether the user can use the software or not. This will be a usability testing. So this is an introduction to show you that there are many types of software testing objective. And get back to this the way that we are going to do software testing is will follow this sentence. Dynamic verification of a behavior of the program on a finite set of test cases, which is suitably selected from a usually infinite execution domain against the expected behavior. Okay. The thing is, there will be more detail on software testing that I want to talk today. But no student, I expect more students to join. So doesn't matter. I will stop here. And I will ask again, what time did that student will prefer for joining the class? I just want more than just 5 or 6, just one student. I don't think that is proper. Please let me know the proper time if you are watching this video. Okay, thanks for joining the class. And I will stop recording.